You know how we hear about quantum computers being able to solve problems in minutes that would take our best supercomputers centuries?
Yeah.
That's the kind of potential we're talking about today.
Wild.
We're diving into quantum computing, past, present, and future, and I'm excited to unpack some of the mind-blowing possibilities in this deep dive.
It really is fascinating
Yeah.
how it all comes down to the difference between classical computers, which use bits,
Right.
and quantum computers, which use qubits.
Okay.
Those qubits operate under the rules of quantum mechanics, which allows for some pretty wild stuff.
Like superposition, right.
Exactly.
That's where a single qubit can be both 0 and 1 at the same time.
Right?
This source actually dives into how that very concept unlocks a level of computational power
It's incredible.
we can barely wrap our heads around.
Yeah, think about it. That means a quantum computer can explore tons of different solutions at the same time, instead of going through them one by one like our classical computers.
So where did this whole idea of quantum computing even come from? Was it always about building super fast computers?
Well, not exactly.
Okay.
It all started with the birth of quantum mechanics back in the early 20th century.
Okay.
Physicists like Richard Feynman and Yuri Manin realized that our classical computers were hitting a wall
Interesting.
when it came to simulating the quantum world.
It's like trying to explain the ocean with a drop of water.
Yeah,
You're just not getting the full picture.
a great analogy.
Yeah.
And it was Paul Benioff who, in 1980, proposed the first quantum mechanical model of a computer.
Wow.
And then Feynman himself
Uh.
really emphasized how vital computers based on quantum mechanics would be to understand the world around us.
Yeah.
It's a whole new approach to computation.
And then in 1985, David Deutsch came up with the concept of a universal quantum computer, essentially a machine that could simulate any physical process.
Yeah.
But when did the idea really take off?
I'd say the turning point was
Yeah.
in 1994, when Peter Shor developed his algorithm for factoring large numbers.
Interesting.
What's interesting is it wasn't just a faster way to factor.
Okay.
It was exponentially faster than any classical algorithm.
That's a big deal. Huge. Especially for cryptography, right?
Oh, yeah.
Because most encryption schemes are based on factoring large numbers.
That's right.
That's where the idea of quantum computers cracking codes comes from.
Precisely. That's what sent everyone into a frenzy trying to
Yeah.
build these things.
Right.
And now, researchers are even working on entirely new encryption methods that can withstand the power of quantum computers.
Okay, so that's a bit of history, but where are we now? Have we
Yeah.
made any real progress since those early days?
Well, we've definitely seen some incredible breakthroughs.
Okay.
Researchers have built small-scale quantum computers using different technologies like trapped ions and superconductors. Sort of like the early days of classical computing, where different approaches are being explored at the same time.
That makes sense. So it's not just one type of quantum computer being developed.
Right. It's kind of a quantum zoo out there.
Wow.
Each technology has its own strengths and weaknesses.
Oh.
For instance, trapped ions offer incredible accuracy, but scaling them up is a challenge.
Right.
Then you have superconducting qubits,
Uh-huh.
which are easier to scale,
Yeah.
but are more susceptible to noise.
That's fascinating. It sounds like it's not just about building bigger quantum computers.
That's right.
But also about finding the most stable and reliable technology.
Exactly.
Which one is leading the race?
It's too early to declare a winner.
Okay.
The field is evolving so rapidly that new breakthroughs are happening all the time.
Wow.
For instance, silicon spin qubits are gaining traction because they have the potential to be integrated with our existing silicon-based technology.
That's interesting. So the same material that powers our laptops could also hold the key to the quantum future.
Exactly. And then there are photonic qubits,
Okay.
which use particles of light, and neutral atoms trapped in optical lattices.
Wow.
Each approach has its own advantages and drawbacks.
It's amazing to see how all these different technologies are being explored simultaneously. But with all this variety, how close are we to actually seeing practical applications?
Well, that's where things get really interesting.
Yeah.
While we're waiting for fault-tolerant, large-scale quantum computers,
Right.
researchers are already finding clever ways to use what we have.
Okay.
This quantum computing, past, present, and future source, actually points to something called hybrid quantum classical computing
Oh, interesting.
as the next big step.
What's that all about? Is it a way to get the best of both worlds?
Precisely. In a hybrid approach,
Okay.
we use classical computers for tasks like data preparation and error mitigation, while the quantum processor tackles the computationally intensive parts.
So it's like having a specialized team where each member focuses on their strengths.
Exactly. And that's opening up some exciting possibilities,
Yeah.
even with the limited quantum computers we have today.
This is all so intriguing. It's amazing how much research is happening, but I'm curious, are there any specific examples of this hybrid approach at work? I mean, are we seeing any real-world results yet?
Oh, absolutely.
Okay.
For instance, in the field of materials science, researchers are using hybrid quantum classical methods to simulate the behavior of molecules,
Interesting.
which could lead to the discovery of new materials with incredible properties.
So it's not just theoretical anymore.
Right.
We're actually starting to see tangible results.
Exactly. And the applications go beyond material science.
Okay.
Think about drug discovery, where researchers could use quantum simulations to understand how drugs interact with the body at a molecular level,
Wow.
leading to the development of personalized medicine.
Okay.
Really quite remarkable.
Personalized medicine. That's incredible. It sounds like we're on the verge of a healthcare revolution, all thanks to quantum computing.
Yeah, it's really exciting.
But I'm guessing there are still some significant challenges ahead.
Oh, for sure.
What are the biggest roadblocks we need to overcome?
You're right, we're not quite there yet. The biggest hurdle we face is the fragility of those qubits we talked about. They're incredibly susceptible to noise and errors from their environment,
Right.
which can mess up their delicate quantum states.
So maintaining that superposition, that ability of a qubit to be both 0 and 1 at the same time is still a major challenge.
Exactly. It's crucial because that's what allows for all that parallel processing power
Mm-hmm.
and to achieve what we call quantum advantage,
Okay.
where a quantum computer consistently outperforms any classical computer
Right.
for specific tasks.
Mm.
We need not only to maintain those states,
Right.
but also to scale up the number of qubits significantly.
That sounds like a monumental task. How are researchers even approaching a problem like that?
One exciting area is error mitigation.
Okay.
It's not about completely eliminating errors, which is incredibly difficult,
Yeah.
but rather minimizing their impact on the final result.
Okay.
Think of it like taking a picture on a shaky boat. Error mitigation would be like using software to combine multiple blurry pictures and create a clear one.
So it's about working smarter, not harder,
Exactly.
with the qubits we have now. What I find fascinating is this idea of quantum advantage. You mentioned it depends not only on the number of qubits, but also on the type of problem.
Right.
Can you give me an example?
Sure. Imagine you're a pharmaceutical company trying to design a new drug.
Okay.
You need to understand how that drug will interact with the human body at a molecular level.
Uh-huh.
Simulating that interaction is incredibly complex for a classical computer,
Right.
but it's a task tailor-made for a quantum computer.
Because it can explore all those possible interactions simultaneously, right?
What?
That's where the power of superposition really shines. But what about something like financial modeling?
Yes,
I've heard that's another area where quantum computers could have a huge impact.
absolutely. Quantum computers excel at optimization problems,
Okay.
which are at the heart of financial modeling.
Mm-hmm.
Think about portfolio optimization or risk assessment. These are complex calculations involving vast amounts of data and multiple variables.
Right.
A quantum computer could analyze all these factors simultaneously
Yeah.
and find optimal solutions much faster than a classical computer.
So we're talking about potentially making better investment decisions,
Exactly.
managing risk more effectively,
Ah,
and even predicting market trends with greater accuracy.
yes.
That's a game changer for the financial industry.
Precisely. And these are just a few examples.
Wow.
Quantum computing could revolutionize fields like materials, science, logistics, artificial intelligence, and even climate modeling.
Wow. It's mind-blowing to think about the sheer breadth of potential applications.
It really is.
It seems like quantum computing has the potential to impact nearly every aspect of our lives.
It really does. And that's what makes this field so exciting.
Yeah.
We're still in the early stages,
Yeah.
but the possibilities are endless.
But with all this potential comes a sense of responsibility, right?
Yeah.
What about the ethical implications of a technology this powerful?
You're absolutely right.
The source does touch upon the societal impacts of such a revolutionary field.
That's a crucial point. As with any transformative technology, we need to be mindful of the potential risks and challenges.
Right.
We need to ensure that quantum computing is used for good and benefits all of humanity.
So it's not just about the science and engineering, it's about the values we bring to it. What are some of the specific concerns people have raised?
One concern is equitable access.
Okay.
We need to ensure that the benefits of quantum computing aren't limited to a select few wealthy nations,
Right.
large corporations,
Yeah.
powerful institutions. We need to make sure this technology is accessible to researchers, developers, and entrepreneurs from all backgrounds in all corners of the world.
Because the best ideas can come from anywhere.
Exactly. We need to foster a diverse and inclusive quantum workforce
Yeah.
to ensure that the development and applications of this technology reflect the needs and perspectives of all of humanity.
That makes a lot of sense. What about other concerns? I've heard people talk about the potential for misuse of this technology, especially when it comes to things like encryption.
That's a valid concern.
Yeah.
The ability to break existing encryption schemes could be a double-edged sword.
Right.
In the wrong hands, it could be used for malicious purposes, stealing sensitive data,
Yeah.
disrupting critical infrastructure, undermining national security.
Right.
That's why it's essential to develop robust security measures,
Yeah.
ethical guidelines,
Okay.
and international regulations for the use of quantum computers.
So it's like any powerful tool, it can be used for good or for ill. And it's up to us to ensure that it's used responsibly.
Precisely. And another important consideration is transparency and accountability.
Okay.
Quantum algorithms can be incredibly complex,
Right.
making it difficult to understand how they reach their conclusions.
Uh,
This raises questions about fairness and bias,
yeah.
especially when these algorithms are used in areas like healthcare, finance, or criminal justice.
That's a great point. We need to make sure these systems are making decisions that are fair, unbiased, and understandable, even if the underlying algorithms are incredibly complex.
Exactly. And that's where the field of explainable AI comes in.
Interesting.
Researchers are working on techniques to make the decision-making processes of complex algorithms more transparent, even in the quantum realm.
So it's not just about getting the right answer.
Yeah.
It's about understanding how we got there and making sure the process itself is ethical and responsible.
Absolutely. And that requires a multidisciplinary approach
Yeah.
involving not just computer scientists and engineers,
Okay.
but also ethicists, social scientists, legal experts, and policymakers.
Wow.
We need a collective effort to shape the future of quantum computing in a way that benefits all of humanity.
This deep dive has been incredibly insightful. We've covered so much ground, from the science behind quantum computers to the ethical implications of this technology.
It's fascinating, isn't it?
But I'm curious, amidst all this innovation, who are the major players driving this quantum revolution? Who should we be keeping an eye on?
It's a truly global effort with researchers and companies all over the world
Right.
pushing the boundaries of what's possible. But some names definitely stand out.
Like who?
Well, IBM has been a pioneer in the field for decades.
Okay.
They've made significant strides in developing superconducting qubit-based quantum computers.
Wow.
They even have a platform called IBM Quantum Experience,
Oh,
which gives people access to their quantum computers via the cloud,
really?
making this technology more accessible to researchers and developers worldwide.
That's impressive. Making quantum computing accessible to a wider audience could really accelerate progress.
Absolutely. And then there's Google,
Okay.
which has been making headlines with its achievements in demonstrating quantum supremacy, meaning their quantum computer outperformed a classical computer for a very specific task.
It seems like every few months there's a new breakthrough being announced.
It's a fast-moving field.
What about Microsoft? I know they're also a major player in the tech world.
Yes.
Are they involved in quantum computing as well?
Oh, definitely.
Okay.
Microsoft has its Azure Quantum Platform,
Okay.
offering a cloud-based ecosystem that gives users access to a variety of quantum hardware and software tools. They're focused on making quantum computing more accessible and easier to use for businesses and developers.
It's fascinating to see how these tech giants are all vying for a leadership position in the quantum computing space. But it's not just the big players, is it?
Right.
What about smaller companies and startups?
You're right. There's a vibrant ecosystem of startups
Okay.
pushing the boundaries of quantum computing in various ways.
Interesting.
Companies like IonQ are focused on trapped ion quantum computing. D-Wave Systems specializes in a specific type of quantum computing called quantum annealing,
Okay.
which is great for optimization problems.
Right.
And Rigetti Computing is working on superconducting qubits.
It's incredible how much innovation is happening across the board. It seems like every company is approaching quantum computing from a slightly different angle. But with all this competition, is there any collaboration happening as well?
Absolutely. One of the great things about the quantum computing field is the spirit of collaboration.
Oh, that's
There's a
nice.
strong open source community where researchers and developers are sharing their code, tools, and knowledge.
Yeah.
This open approach is really accelerating progress and helping to democratize access to this technology.
It's inspiring to see that kind of collaboration, especially in a field with so much potential for commercial applications.
It is.
But speaking of potential, I want to bring it back to our listener. With all this talk of breakthroughs and future possibilities, what does this all mean for someone who's not a physicist or a computer scientist? How will quantum computing actually impact their everyday life?
That's a great question. And honestly, it's still a bit early to say for sure.
Yeah.
The field is moving so fast, and it's hard to predict exactly when and how quantum computing will transform our world.
So should we just wait and see what happens?
Waiting passively might not be the best approach.
Okay.
I think it's important to stay informed about the latest developments in quantum computing
Yeah.
and engage in conversations about its potential impact on society.
Uh,
Even if you're not a technical expert, you can still participate in shaping the future of this technology.
what do you mean by that? How can someone who's not a scientist or engineer contribute to the development of quantum computing?
Well, for one thing, you can simply learn about the technology and its potential applications.
Okay.
Read articles, listen to podcasts,
Right.
attend webinars. There are so many resources available to help people understand the basics of quantum computing.
That makes sense. The more people understand this technology, the better equipped we'll be as a society to make informed decisions about its development and use.
Exactly. And you can also engage in discussions about the ethical implications of quantum computing. Talk to your friends, family, colleagues. Raise awareness about the potential benefits and risks of this technology.
It's about having those crucial conversations now, before this technology becomes so widespread that it shapes our world without our input.
I agree.
What else can people do to get involved?
Support initiatives that are promoting equitable access to quantum computing education and resources.
Okay.
Encourage young people to explore STEM fields, especially those related to quantum computing.
All right.
These are the future innovators who will shape this technology and its impact on our world.
It's inspiring to think about the potential of quantum computing to solve some of the world's most challenging problems.
It is.
But it's also important to remember that technology is a tool,
Yes.
and like any tool, it can be used for good or for ill.
Right.
It's up to us to guide its development in a way that benefits all of humanity.
I couldn't agree more. The future of quantum computing is in our hands.
Yeah.
It's a future we create together.
It sounds like we're nearing the end of our deep dive into quantum computing, past, present, and future.
Yeah, it's been a great conversation.
Is there anything else you'd like to share with our listener before we wrap things up?
Just one final thought. As we embark on this quantum journey,
Yeah.
it's essential to approach it with a sense of wonder and curiosity, but also with a healthy dose of critical thinking and a commitment to ethical considerations. The quantum realm is full of possibilities,
Right.
and it's up to us to ensure those possibilities lead to a brighter future for everyone.
It's incredible to think about the possibilities, but I have to admit, it's also a bit daunting. This whole field is moving so fast, and for someone like me who's not a quantum physicist, it's hard to keep up.
Yeah.
Any advice for our listeners who might be feeling a little overwhelmed by all this quantum talk?
I think it's important to remember that you don't need a PhD in physics to appreciate the significance of quantum computing. Just like you don't need to know how a combustion engine works to drive a car, you don't need to understand the intricacies of quantum mechanics to grasp the potential impact of this technology.
That's a good point. It's more about understanding the big picture, the potential benefits, and the challenges we need to address as a society.
Exactly. And even if you're not a technical expert,
Mm-hmm.
you can still participate in shaping the future of quantum computing. Stay curious, ask questions,
Okay.
engage in conversations about the ethical implications.
Yeah.
The future of this technology is too important to be left solely in the hands of scientists and engineers.
So what's the best way for our listeners to stay informed? Are there any specific resources you recommend?
There are tons of great resources out there.
Okay.
Many universities and research institutions have websites dedicated to quantum computing with articles, videos, and even online courses.
Nice.
And of course, there are plenty of books and podcasts like this one
Yeah.
that delve into different aspects of this field.
It seems like there's something for everyone, regardless of their technical background.
Absolutely.
Yeah.
And don't be afraid to reach out to experts in the field,
Okay.
whether it's a professor at a local university or a researcher at a tech company.
Mm.
Most people who work in quantum computing are passionate about their work and eager to share their knowledge with others.
So it's about tapping into that network of experts and learning from those who are pushing the boundaries of this field.
Exactly. And don't underestimate the power of simply talking to people about quantum computing.
Uh-huh.
Share what you've learned with your friends, family, colleagues.
All right.
The more we talk about this technology, the better equipped we'll be as a society to make informed decisions about its development and use.
It's about sparking that curiosity and demystifying this field that often seems so inaccessible to those outside of the scientific community.
Precisely. And who knows, maybe one of our listeners will become so inspired by this deep dive that they'll decide to pursue a career in quantum computing. We need all the bright minds we can get to help shape this exciting future.
Speaking of the future, as we wrap up this deep dive, I want to leave our listeners with a final thought-provoking question. Imagine a world transformed by quantum computing. What excites you the most about that future, and what concerns you the most?
For me, the most exciting prospect is the potential to solve problems that are currently intractable with classical computers. Imagine being able to develop personalized medicine that targets diseases at a molecular level, or designing new materials with properties that revolutionize entire industries, or even understanding the mysteries of the universe in ways we can't even fathom today.
Those are some truly inspiring possibilities, but you also mentioned concerns. What are some of the things we need to be mindful of as this technology continues to evolve?
I think one of the biggest challenges will be ensuring equitable access to the benefits of quantum computing.
Right.
We need to make sure this technology doesn't exacerbate existing inequalities or create new ones. It's crucial that the benefits of quantum computing are shared widely and don't become concentrated in the hands of a select few.
That's a crucial point. It's not enough to simply develop this technology. We need to ensure it's used in a way that benefits all of humanity. Any other concerns?
Another challenge will be managing the potential risks. As with any powerful technology, there's always the possibility of misuse. We need to be proactive in developing safeguards to prevent quantum computing from being used for malicious purposes.
Right.
Whether it's breaking encryption, developing autonomous weapon systems, or spreading misinformation.
So it's about striking that balance between harnessing the incredible power of quantum computing while also mitigating the potential risks.
Exactly. It's a complex challenge, but I'm optimistic that we can find solutions if we approach it collaboratively and thoughtfully. It's a challenge that requires the collective wisdom of scientists, engineers, policymakers, ethicists, and everyday citizens.
It's been a fascinating journey exploring the world of quantum computing. We've covered so much ground, from the mind-boggling science to the profound ethical implications. Any final words of wisdom for our listeners as we wrap up this deep dive?
Just this: stay curious, stay engaged, and stay hopeful. The quantum realm is full of wonder and possibility, and it's up to all of us to shape its future.
That's a perfect note to end on. Thank you for joining us on this incredible deep dive into quantum computing. We hope you've enjoyed the journey and learned something new along the way.
It's been a pleasure. Until next time, keep exploring, keep learning, and keep asking those big questions.
And who knows, maybe one day you'll be the one making groundbreaking discoveries in the quantum realm.